All right, recording and rolling. It's Thursday, November 16th. We got today and tomorrow till Thanksgiving break. So main thing today, I got an FRQ for you guys. It's on your desk already, so we'll do that pretty soon. All right. You guys remember, make sure you've got everything turned in by tomorrow. Over Thanksgiving break, I'm gonna finalize grades for the interim report. And at least a couple things to keep your eye on. Remember this momentum half page. A lot of you guys have already turned this in, but if you haven't, make sure it's in the grade tray before you take off for the break. Chapter 6 puzzles. I think we've covered all these in class except for this ballistic pendulum, but this one even got its own poster. If you just follow the poster, but you guys can figure that out. And of course, as always, the solutions are posted, so you can check the work there. So I'll bet tomorrow. In-class quiz tomorrow. We did the review for that yesterday. Remember, it's going to be on both energy and momentum. This is not going to be as difficult as AP type material is because it's designed for all the class. Okay, so you guys know that. And before we do this FRQ, a momentum problem that we never actually solved. That I did throw at you guys. You guys remember that Magic School Bus clip? All those kids were on the frictionless field, and I said you could use what we're doing, last week and this week to solve like here. If you know the mass of the pitcher, the mass of the baseball, and how fast the baseball is headed towards the plate, there's enough information there where you can solve for how fast you head back towards second base. You could actually solve this without momentum. You can solve with like dynamics and kinematics, but it's a whole long convoluted process, right? But with momentum, you can solve this pretty quickly. So somebody look at those numbers here. Say like the mass of a baseball, we'll round it a little bit to call it 0.15 kilograms. Let's say her mass was like 30 kilograms, just make some of that. Okay? And let's say she threw this so that relative to, say, the plates in the field, it's going like 20 meters per second relative to a stationary observer. So how fast does she head it back towards second base? All right, who solved that? Who knows how fast? Yeah, what you got, guy? 0.1 meter per second. Exactly, 0.1 meter per second. All right, so here's what I would do. I would say, well, I see masses and velocities, and this looks like a reverse collision, right? Like if you filmed this and ran it in reverse, it would be an inelastic collision, wouldn't it? So you kind of treat it that way. I'll say sum of momentum before the throw is equal to sum of momentum after the throw. I normally say collision. This is like a reverse collision. Or you can think of this like an explosion. There was a grenade problem you guys saw the other day. Okay. And, oh, guys, when she's just standing at rest on the mound with the ball, what's the momentum in the system? 0. So there's only ever 0 kilogram meter per second of momentum in the system. There's only ever 0. Right? Where does it come from? All right. Oh, well, you got a positive and a negative, right? Remember, these are vector quantities. That's what makes this work too, right? So you got mass of the ball, velocity of the ball, plus mass pitcher, velocity pitcher. Right? All right. And I gave you 3 of those 4 values, and the question was how fast she's sliding back towards second base. Right? So you just plug stuff in, right? All right, let's go to that. So 0 equals, got 0.15 kilograms going at 20 meter per second plus, and then I gave her a mass of 30 kilogram and how fast she headed back towards second base. Okay, so subtract this over, divide down the mass, okay, cut through a couple algebra steps. You should get V pitcher is negative 0.10. And oh, units, guys, what's the units on that? Meters per second. Hey, could I call that like 10 what? Centimeter per second. Right. Which may be a little easier to visualize. At least for me it would be, right? It's like that far every second. Okay, right, given all those other numbers. All right, you guys ready for FRQ? FRQ? All right, so let's do the way we've done last couple. I think is pretty good, especially for this one. We'll do just a little bit at a time. Okay, so switch over FRQ.